Hi guys, we have one more example to do today with radical equations. In this example, I have two separate radicals, but they're being separated by a subtraction sign, which means I cannot combine them together. Remember that we learned last week that radicals can only be combined together using adding and subtracting if the underneath part, the radicand, is exactly the same. And in this problem, it's not the same. So what we're going to do in this problem is we're going to keep the complicated radical, the 2x plus 1, we're going to keep that all by itself, and we're going to move the simple radical, the square root of x, to the other side. So we end up having like an adding problem on both sides of our equal sign, but like one of them is completely enclosed in a radical and the other one is not. So notice on the right-hand side that the square root of x is under the radical, but the plus 1 is not. That's going to be important for our next step. And our next step is to square both sides. Now, since the left side is completely contained inside of a radical, the square and the square root are just going to cancel out, and it's going to be okay. On the right-hand side, since the entire side is not inside a radical, the right-hand side is technically a binomial. It's rad x plus 1. That's not the same as the left side. The left side is rad 2x plus 1. Since the right side is a binomial, you'll have to do the same thing that we did on the previous video, which is where you write the parentheses twice and you can use FOILing or the box method to multiply it out. When you're done multiplying it out, unfortunately, there is still going to be a radical in the problem. Our next step is going to be to try to get that radical by itself. So I subtracted this x to the other side. 2x minus x is just x. And then I also took this plus 1 and I subtracted that to the other side as well. And lucky for us on this one, the plus 1 and the minus 1, when we subtracted it, those canceled out. At this point in time, I'm going to try to get rid of the square root symbol again. So this time, though, there's no adding and subtracting in the problem, so it should actually get rid of the square root. So I'm going to square both sides again. On the left side, it's just going to be an x squared. Don't forget when you're squaring this that the number that's not under the radical does actually need to be squared. And then this square root and that square will just cancel. Similar to our first video, in this one, I have an x squared in my equation. And so I need to set this equal to 0, and I'm going to use factoring to solve. So I'm going to minus the 4x to the other side. When I'm factoring, I do like the x squared to be positive. That's the best way to factor. So moving the 4x over. This is not a trinomial. We're not going to do x box. This is a GCF. This has a GCF of the letter x. So I'm going to take out a letter x, and then my two answers, I think, should check them. My two answers are 0 and positive 4. Now, again, just like in the first video, we do want to check our answers. We want to plug them in and see if they work. When you're plugging them in, you're going to plug them back into the original problem. Okay, so here I'm checking the number 0. Over here, I am going to need to simplify this down to a single number before I can square root it. The square root of 1 is 1, and 1 minus 0 is 1. So I'm going to go ahead and say that 0 is an answer to this problem. Now, it is possible that both numbers are answers. That is a possibility, so I should check my other number. I'm not going to assume that the other one is extraneous. So I'm going to plug in my 4. The square root of 9 is 3. And 3 minus 2 is also 1. So in this problem, they both end up being answers. So again, you can't just assume that you're always going to get one that works and one that doesn't. It is possible that they both work, and it's also possible that neither of them work. So always check your answers. Here's one for you to try on your own before I leave you for the day. Once you're done with this problem, unpause the video and check and see how you did. All right. In this one, I did get an extraneous answer. So 9 does work, but 1 does not. 1 is extraneous. Make sure to keep checking for those extraneous solutions, and I'll see you in tomorrow's final video for this chapter.